There's a special kind of matrix in the matrix world. It's a square matrix with ones on the diagonal and 0 everywhere else. That matrix is called the identity matrix. So this is what it looks like in reality. It's 1 on the diagonal, so 1 in the main diagonal all the way through, and everything else in the matrix is a bunch of zeros. All the numbers that you see everywhere else are pretty much all zeros. That is called the identity matrix because when you multiply it with any other matrix, you get the original matrix back. So let's give it a shot. A is 4 and -7, -3 and 2. Let's multiply that with the identity matrix. In this case, it's 1, 0, 0, 1. So it's called an identity matrix because all the numbers on diagonal are 1. And as you can see, when I multiply, let's give it a shot. 4, -7 gets multiplied with the 1 and 0. We just get 4 back. If I multiply 4 and -7 with 0, 1, I'm going to get -7 back. And then again, if I multiply the 4, -7, the -3, 2 with the 1, 0, I'm going to end up with -3. And finally, if I multiply the -3, 2 with the 0, 1, I'm going to see at the end the number 2. So the answer that I got is the original matrix A. Right? I started by multiplying A times the identity, and I got the A back. So in this section, or in the world of matrices, this identity matrix is called the multiplicative identity. Why is it called that way? It's called that way because when you multiply it by anything else, you just get this original thing back. You never change the problem, right? And you can do it in any order you want. You can multiply it first, you can multiply it after. Does not matter. The answer is always going to be whatever matrix you had next to it. So in this case, if I do 4, -7 and -3 and 2, if I multiply these two matrices, again, I'm going to get 4, -7, -3 and 2. So again, this is equal to the original matrix A that was written over here. So again, we know that identity does not change the product. It's kind of like the 1. If you multiply 1 by any other random number, you get the original number back. Same thing with the identity matrix. If you multiply by any other matrix, you get the other matrix back. Now sometimes you end up multiplying two matrices and they end up giving you the identity matrix. In that case, we call the matrices inverses of one another. So if two matrices multiply together, and they give you an identity matrix, those matrices are called inverses of one another. So let's give it a shot over here with A and B. They're saying check that A and B are inverses of each other. So all I have to do to check is multiply them and verify at the end that the answer I get is going to be the identity matrix. Notice that the numbers don't have fractions or anything, but somehow when you multiply them, you get back the identity. Let's give it a shot. So multiply this with this. 4 times -2 is going to be -8. -3 times -3 is going to be +9. Okay, so next we're going to multiply the 4, -3 with the 3, 4. So if you multiply them, you're going to get 12 and then -12. Cool. Now what about the 3, -2 with that? So 3 times -2 is going to be -6. And then -2 times -3 is going to be +6. And finally, the last row with the last column. So 3 times 3 is going to be 9. -2 times 4 is going to be -8. And if you add up the numbers, we get 1, 0, 0, 1 again. So what does that mean? That means I multiplied the matrix A and B and I got the identity back. So that means that A and B matrices are inverses. A and B are inverse matrices. Now, you can see that it took like a while to write down the sentence and it's a lot of words. Instead of writing down the words, here's what we're going to normally write. We're going to say that B is A with the power -1. This is the symbol. That means that A and B are inverses of each other. So having the exponent -1 just tells me that some matrix is the inverse of another one. Okay? And in general, if you multiply a matrix with its own inverse, the answer is going to be the identity. And this happens in any order. You can put the inverse matrix first, multiply by the matrix itself, you're still going to get the identity back. Okay, so that's a special thing. And, you know, finding inverse matrices is really difficult in general, but calculators can make it super easy. So I'm not going to make you do it by hand. I'm just going to tell you to find the inverse matrices with a calculator. So suppose I wanted the inverse of the matrix A that was in this problem. How can I go about finding the inverse on the calculator? Well, first of all, I'm going to go into the second matrix menu and then again edit to put the data in for the matrix A. The matrix A is a 2 by 2, so I'm going to type those numbers in first for -3, 3, and finally -2. And once I'm finished, I'm just going to leave the matrix menu and I'm just going to type in now second matrix, colon A, and then just type the -1. That puts a -1 in the exponent. This way the calculator knows I'm now searching for the inverse function, or the inverse matrix rather, of the matrix A. And I'm just going to click enter, and there it is, -2, 3, -3, 4, which are exactly the numbers of B. So B is going to be known as the matrix inverse of A, and vice versa, A is the matrix inverse of the matrix B.